Mm. Hello everyone, so welcome to my presentation. Today I'm incredibly excited to introduce you about my new project. It's called Timer. In a world where almost every electronic device is controlled by a microcontroller or a few lines of code, I wanted to take a step back and embrace the raw beauty of digital logic. Timer is a fully functional, adjustable countdown and clock timer built entirely using pure hardware components. No Arduino, no coding, just pure physics and logic gate. First quick look at the pile of materials that make it possible. First is the iterative circuit for CD4011 PE counter, one NE556 Dual Timer, one CD4011 Quad, NAND Gate, and about display and UI for 7 segment display and 3 tactile button for set, start, and reset. Basic component, a specific network of 10k ohm and 68 kilo ohm resistor, 10 and 407 microfarad electrolytic, and 10 nanofarad ceramic capacitor for timing and debouncing, plus a 100 kilo ohm variable resistor paired with a 1k ohm fixed resistor for adjustable speed. And this is the circuit schematic. Let me break down how each part works together. The heart of our timing relies on the NE556 Dual Timer. One half of this IC is configured with the 68 kilo ohm resistor and 10 microfarad capacitor to generate a highly precise one-hz waves for our real-time countdown. The other half utilizes the 100 kilo ohm variable resistor to create a faster adjustable frequency signal used for setting the time quickly. And to reset the signal, we use for CD4011 PE chips. These are fantastic CMOS chips because they handle both the decay up, down, counting, and the 7-segment display decoding all in a single package, especially reducing wiring. And finally, the CD4011 Quad N-Gate acts as our traffic controller. It provides a hardware housing for our tactile bottom so we can get clear signal, and it functions as an SR latch. Depending on whether you press R or set, the gates roll either the fast pull to the clock up pins or the one-hand pull to the clock down pins. Now we will see in protect for simulation. And turn on the switch. First, we will push the reset button to clear on display to 0. And next, we enter the setup phase. As I hold the set button, you can see the high frequency pulse from the 556 timer bypassing the countdown logic and routing directly to the counters. Once our time is set, I press start. You can see the logic gate immediately look at the setup signal and switch the one-head countdown mode. Notice that the cascading logic when the second rollback past 0, the circuit successfully borrowed from the 10 to minute target until the entire display reached the exact 9999. So of course, theory and simulation are one thing, but reality is another. So transition from project to a physical PCB brought some very real hardware engineering challenge. The final result is a rock-solid, highly responsive physical timer. The bottom feels enormously, and the counting is perfectly precise, and the display are bright and stable. And to prove the accuracy of our core timing circuit, I will measure the one-head frequency output directly from the NE556 using the measuring instrument. So here you can see the frequency is approximately one hertz. So let me show you guys how it works in real time. So first I will turn on the switch, and then I push the reset button. So then I set the time, like here I want 15 seconds. at about 15 seconds, and then I restart. So it will count down. So timer were an amazing journey into the fundamental of digital electronics. Taught me that while software about full, there's something incredibly satisfying about solving complex logic problem using poor raw hardware. So thank you for your time, and I would be happy to answer any question you have about the schematic, the troubleshooting process, or the PCB design. So goodbye.